Hey guys, and welcome back to another day of Notes 1.1. Today, we're going to talk a little bit more about some other stuff. Mostly, we're going to talk about variables. So, get excited for that. Let's talk about variables. First, what I've got for you is a graph. I totally made it up. I think this is based on how it is, but sometimes it's not. This is a scientist, me, made the following graph by surveying a group of 300 construction workers. Again, I didn't actually survey these construction workers, totally made up this data. So here's what I want you to take a look at. Take a look at the axes. Here's my x-axis over there, where I have yearly salary. Here's my y-axis, where I have happiness. So we're comparing a worker's salary to his overall happiness, kind of how that changes. Now, here's the thing. When you see a graph like this, we want you to be able to read and interpret it. So I've got a couple questions, and these are questions that will show up on like an ACT when you take that junior year. So these are great skills to have, great skills to know, and know that they're not going to go away as you move forward in your education. No matter where you want to go, you're going to need to know how to read a graph. So, here are three questions for you. The first question says, what did the scientists know to be different about the workers before the study? What did the scientist measure with the study? And what did the scientist make sure was the same? So think about this based on a scientist making a graph, surveying a group of 300 construction workers. What did they know ahead of time? What did they find out? And what did they want to make sure was the same as they were doing the study? Hopefully you got answers. If not, pause it. Let's go over them. What did they know to be different about the workers? The amount of money they made, right? So here down where it says yearly salary, this is the amount of money a construction worker was making. So they knew that before they even started the study. They had these 300 construction workers, and some of them might have had similar salaries. Some of them might be exactly the same, but there's probably a wide range of different salaries. What did the scientists measure during the study? If they already knew yearly salary, the only other thing that they measured was happiness. So here they're looking at the construction workers' happiness. And then what did the scientists make sure was the same? The type of job, right? This wasn't just workers in general. This was specifically construction workers. Think about it. Maybe a construction worker has less fun on his job than like, I don't know, someone who gets to pet dogs for a living, or like an ice cream taster. Ice cream tasters might in general be more happy. So in this case, it was just construction workers. So the job was the same, but the amount of pay was pretty much kind of the idea is that's the only thing that's different. And then they're looking at how happy are they. So this is, I would say, a pretty good experiment in terms of the way it's designed. Let me tell you a little bit more about that. A good experiment is going to have one variable that we already know. That's what we call an independent variable, the amount of money that someone makes. Now, happiness is the one variable they're measuring. That is what we call a dependent variable. And then the other thing that makes a good experiment is that you want to have a bunch of control variables. You want to make sure that the only two things that are unique is the construction workers' pay and then looking at their happiness. Everything else should try and be as much the same as possible, right? So obviously, like construction workers might have different number of family members. Maybe they have, some with one kid at home, some with no kids at home. As much as possible, you'd want to make sure they have the exact same kids. Maybe they have the exact same marital status. I know my overall happiness has increased since getting married. Anyways, stuff like that. They want to make sure that's all the same type deal. Cool. So these are the three terms we're going to talk about today: independent, dependent, and control variable. So here's the definition for independent variable. Independent variable is something that is, we say, deliberately changed by a scientist in an experiment. So this is the variable that we know to be different. For example, if you're measuring the amount of dogs that it takes to be happy, in this case, the amount of dogs someone has would be the variable that deliberately changes. We're going to look at some people with no dogs, some people with one dog, some people with two dogs, right? So anytime you're picking an independent variable, that's the one that's deliberately changing. A classic example would be time, right? Let's say you're measuring how fast someone runs. Time is the thing you're deliberately changing because you want to see how they move as time changes, if that makes sense. A dependent variable is whatever you're measuring as a result of the changes. So in any experiment, you need to have one thing that's different, and then you have to measure something else to see how one thing relates to the other thing. That's kind of the idea, is we want to see, are they related in any way? Do they not seem related? And then we kind of go from there. So the dependent variable, always on the y-axis, and it's always the thing that you're measuring. So if you're measuring volume, volume's your dependent variable, right? So maybe you're measuring the volume of gas as temperature changes. So temperature is the thing you're slowly increasing, you're slowly heating up a gas, and then you're measuring the volume as a result. And then a control variable is anything else. And this is something that you really kind of have to think about. You have to go through kind of each step of your procedure, or you have to think about, what am I studying? Why am I doing it? And think, how can we make sure that everything else that could affect our measurement is kept as constant as possible? So you want to keep control variables constant, and it's any variable that is not the independent or dependent variable. So for example, in that idea of temperature versus volume, you would want to make sure that the amount of gas stays the same. You'd want to make sure that the pressure of the gas stays the same, and so on and so forth. Here are a couple of examples of experiments that I just made up. So one's about Mr. Polthin. Here's what I want you to do. I want you to identify the independent and the dependent variable, and then here's the tricky part. Think about control variables. Try to come up with at least two. I came up with a couple more. Go ahead, take a look at this. Mr. Polthin wants to see if water boils faster in a small pot, a medium pot, or a large size pot. Identify independent, dependent, and then the two control variables. Go. All right, hopefully we're back. If not, pause it. Here's the independent variable. It's pot size. Either it's small, medium, or large. Dependent variable is the speed of the water boiling. So you might even say that it's the time it takes for the water to boil. In this case, time is dependent, right? Because we're looking at pot size. Some control variables. Here are two that I came up with. The type of liquid. You wouldn't want to boil water in one case and then alcohol in another case, or oil in another case. The amount of water or the amount of liquid you use, right? You want to make sure that's the same. If you fill up a small, medium, and a large size pot the same amount of fullness, that's different amounts of water, right? Water initial temp. You don't want to put hot water in one, cold water in the other. The amount of heat, right? So how high you're cranking your stove up to, for example. Room temperature, right? If it's a hotter room, maybe the water is a different temperature. Room elevation, right? If you're in the mountains, stuff boils faster. So if you take one experiment in the mountains and then you move down to like back here and take the other experiment, that's going to totally throw off your data. Why would you do that? Don't do that, right? Room pressure is also huge, right? If it's like a super muggy and pressury day, I don't know. I don't really know how pressure affects weather. I should probably know that, scientist. But anyways, different room pressures could make a difference, right? Maybe you have a highly pressurized room in your house for some reason. Okay, anyways, here's another experiment. Same thing, identify the independent, dependent, and then think of as many control variables as you can. Try and get more than two. Okay, Tima's looking for new running shoes. Wants to know which one is more durable. The independent variable is the shoe brand, right? Because he's looking at Nike, Adidas, or Puma. And then the dependent variable is durability. That's what he's measuring in his experiment. You ready for the controls? Here we go. The time worn, right? If you wear them for different times, they're going to be, you won't have as good of a measurement on how durable they are. Type of activity. If you're running in one and sprinting in the other, that could affect it. Overall distance traveled. If you only traveled 1 mile in one shoes and 10 miles in the other shoes, that's going to throw it off. The type of terrain. If you're on rocky versus smooth. Person wearing the shoes. If you have a really light person or a person who always steps like heel to toe versus toe first. Price of shoe, right? A more expensive shoe, hopefully it's more durable. If you have one that's expensive, one that's cheap, that's going to be different. The size of the shoe, the material of the shoe, the type of shoe, all of these things are things Mr. Tima needs to consider. Here's the deal, folks. When it comes to the experience we're going to run in class, you're also going to have to be on the lookout for control variables. So now let's talk about hypotheses. This is how we kind of put everything together. Here's what a hypothesis is. A hypothesis is an if, then, because statement. So those are kind of like the three key parts of the framework. You need an if, you need a then, and then you need a because. After your if comes your independent variable. After your then comes a statement on how the dependent variable will change. And then the because is your reasoning. This is kind of like a format. This is kind of like a formula. Now, that probably doesn't make any sense right now. So let's use one of the examples we just talked about. Oops. So one of the examples we just talked about was the polythene pot boiling experiment. And the question was, how fast will different sized pots boil water? That was the question. So remember, the independent variable we said was the size of the pots, big, medium, or small. The dependent variable was the speed at which water boils. And now it's your time to make a hypothesis. So if independent variable, size of the pots, then dependent variable, what's going to happen? Do you think it's going to boil faster or slower based on the size of the pot? And then a because. And that's where you get to say why you think something will happen. It doesn't have to be correct. It just has to be your own information. So here's my example of a hypothesis in Mr. Polythene's case. I said, if water is boiled in different sized pots. So here, different sized pots, that's my independent variable. Then the small pot will boil the water the fastest. See how I'm making a statement about the speed in which the water boils? I'm saying the small pot will boil it fastest. So I'm kind of saying what I think will happen, what I think the data is going to look like. And because I said it will contain the water the best. Now, that's bad reasoning. It actually turns out that if you do this, the bigger pot will boil the water faster just because it's the same amount of water in all pots. So the bigger pot will have more surface area. So it'll be able to heat the water more water will have easier access to air and it'll evaporate faster. I'm pretty sure that's what happens. Okay, so here's another example. Same thing, if, then, because. Now we're talking about the shoe durability statement. The question was, which brand of shoe will be the most durable? So shoe brands, we're either looking at Nike, Puma, or Adidas. Durability is our dependent variable. So go ahead now, find your if, find your then, find your because, and make a statement about Tima's shoes. Great, hopefully you made a statement. Here's mine. My statement is, if Mr. Tima test wears 3 different shoe brands, then the Nike shoe will be the most durable. And I just said because it's the highest quality product. I don't know. I kind of phoned it in there for the reasoning. Anyways, that's hypothesis. Let's move on now to talking about the airplane activity. Here's what you're going to do. You're going to create a paper airplane. And you're going to try to create one that flies the longest distance. That's the goal. So right away, you know what our dependent variable is. The dependent variable is distance. Here's the independent variable. How can the weight of a paper affect the distance it can fly? So what we're changing here is the weight of the paper airplane. You'll use regular computer paper and then maybe some heavier paper and then maybe some lighter paper. So what do you think are the independent, dependent, and control variables here? Go ahead and talk about it. Or don't talk about it, think about it. Be about it. Independent variable is going to be something like weight. It's not designed. Oh my gosh, let me get rid of that. Dependent variable is going to be the distance, and then control variables, you're going to have to keep the speed you throw it constant. You're going to have to keep the height you throw it constant. And you're going to have to keep your airplane's shape and design also constant. So those are 3 things you're going to have to be super careful with. Now, we're going to compare this data as a class. So we're going to have to come up with rules on how you can throw your paper airplane, how high you can throw your paper airplane from. But we might be able to do different shapes. I'm not really sure. Maybe we'll all have to make the same type of airplane. That'd be pretty cool. Okay, so that's what's coming up in this class. Here's a review of all the vocab we've talked about. So these are all vocab terms you should have in your thing. Some of these are longer than the ones you have in your textbook. Or in your notes. That's okay. It's not the end of the world. Just make sure that your definitions kind of match up, or you can see how my definition applies to yours. So pause the video if you need more time. Quiz 1.1 is around the corner. Expect questions like you see here. So pause the video if you need more time to think, okay, these are some questions that are going to come up. Identifying independent, dependent, and control variables. It's going to be very similar to what we just did. Writing a hypothesis. Well, we didn't talk about that. And then also applying vocabulary terms like scientific theory, scientific law, technology, quantitative, and qualitative. So all those things are things you're going to have to do on the quiz.